16.4a, Introduction to Graphing a Parabola. Quadratic equations are equations that are written in this form: y is equal to ax squared plus bx plus c, where x is raised to the second power. And when we graph these, we get what's called a parabola. Parabolas can open upward or downward. They all have one y-intercept, but they can have two x-intercepts, one x-intercept, or no real x-intercepts. Another word for an x-intercept is a root. The graph of a parabola is symmetric to the axis of symmetry, which is this imaginary line that divides the parabola in half vertically. And the point, the lowest or the highest point, is called the vertex point of the parabola. So these are what parabolas look like. Like I said, they can either open up or they can open down. They all have one y-intercept. So remember, a y-intercept is where it's crossing the y-axis. So these are their y-intercepts. And they can have two. This would be having two x-intercepts. Here, there's one x-intercept when the vertex is on the x-axis. And then here, there's no real x-intercepts or no real roots. This would have a minimum because it's got a lowest point. This one would have a maximum. And if we were to fold the parabola in half and make it symmetric, that the imaginary line that divides it in half would be called the axis of symmetry. The most basic quadratic equation is written in the form y is equal to x squared. This is called the parent function. Anything we do to this function, y equals x squared, if we add things to it or multiply it by things, then that's given variations to that parent function. The parent function is the basic function of what the graph of a quadratic equation looks like. So a quadratic equation can be graphed by using a t-table, and you can select the values to put in for x and plug them into the equation to get the corresponding y values, and then plot the points on a Cartesian coordinate system. So let's do that here. We're going to graph this parent function by making a t-table, and we've chosen the points for x, and we're just going to plug them into this equation to get our y values. So if I use -3 and I plug it into this equation, y is equal to -3 squared. Well, if I square -3, then I get a positive 9. All right, if I do y is equal to -2 squared, then that would give me -2 squared, which is 4. -1 squared would be 1. 0 squared would be 0. And then we know if we square 1, we get 1. If we square 2, we get 4. And if we square 3, we get 9. So let's plot those points on this graph. All right, so this would be our ordered pair, our x and our y, -3, 9. So I'm going to go to the left 3 and up 9. -2, 4, to the left 2 and up 4. -1, -1, -1, -1, 0, 0. All right, then I have a positive 1, 1, a positive 2, 4, and a positive 3, 9. And then if I just connect these dots, I have the graph of my parabola. All right, so that's that's the parent function. That's what that most basic function looks like. Now we're going to graph y is equal to -x squared using a t-table of 7 values. So we're just going to do the same thing. So this time y is equal to negative, and then I'm plugging in a value for x. squared. Okay, so this would be y is equal to negative, and then negative 3 becomes a positive 9, but there we have that negative value, so that would be a negative 9. All right, then if we do the same thing for negative 2, y is equal to negative 2, which would give me that negative stays there, and the negative 2 becomes positive, which gives me a negative 4. All right, y is equal to negative 1 squared. So the negative 1 becomes a positive 1, but I have this negative in front, so that's negative 1. And then 0 squared, there's no such thing as a negative 0, so that would just be 0. All right, if I plugged in a positive 1, I have a negative, and then just the 1 is being squared, like that. All right, so then that's still a negative 1. And then it's going to be the same thing. If I plugged in a positive 2, it would come out as a negative 4, and we get a negative 9. All right, so let's graph that. Negative 3, negative 9, negative 2, negative 4, negative 1, negative 1, 0, 0, 1, negative 1, 2, negative 4, and 3, negative 9. All right, so let me draw this out. And that's the graph of y is equal to negative x squared. Now, to label the parts of a parabola, the vertex point is the highest or the lowest point on the parabola. It stands alone and there's no buddy. So we haven't talked about the buddies yet. If we look here at either one of these, the very middle point, or the vertex point, stands alone. But then as we go away, as we move away from the vertex point, if you'll notice, these values, these y values, are the same. We have 1, 1, 4, 4, 9, 9. In the negative x squared, we have, here's our vertex point, and then negative 1, negative 1, negative 4, negative 4, negative 9, negative 9. And that's because it's symmetric. The parabola is symmetric on either side of the vertex. The axis of symmetry is the vertical line that goes through the vertex point that cuts the parabola in half. The equation of the axis of symmetry is always going to be in this form: x equals some number. And it's going to always be whatever the x of our vertex was. So in these equations, well, let me see, are we going to talk about that in just a minute? Yeah, we're going to label these in just a minute. So I'll show you how to get that in just a minute. The parabola's y-intercept is the point where it crosses the y-axis. Every parabola has one y-intercept, and the coordinate of the y-intercept is 0 y. So if we plug in 0 for x, it's going to give us what our y-coordinate is. The parabola's x-intercept or intercepts are the points where the parabola touches the x-axis. And like we said before, it could have 2, 1, or no x-intercepts. So now we're going to label the parts of the first parabola that we drew. Okay, so that first parabola looked like this. The coordinates of the vertex point, so the vertex point is where it turns from going down to up, or if it's the other way around, from up to down, it's the highest or lowest point on the graph. So here's the vertex point of this graph, and that would be 0, 0. The equation of the axis of symmetry, like I said, always starts with x equals, and it's x equals whatever the x is in your vertex. So x equals 0. If I were to draw this on the graph, x equals 0, this would be the line. It crosses through x at 0. That's how we would draw that line. And if you notice, it splits that parabola exactly in half. The coordinates of the y-intercept, the place where it crosses the y-axis, would be right here. So my y-intercept would be 0, 0. And then the coordinates of the x-intercept, the only place that it's touching the x-axis is also right here at the same spot at 0, 0. All right, now we're going to label the parts of the parabola for our y equals negative x squared. Okay, so we're going to do the same thing. We're going to find the vertex, the axis of symmetry, and the two intercepts. So let's go back and look at the graph. Well, the vertex of this parabola is also at 0, 0. Let me just write it here. So the vertex is 0, 0. The axis of symmetry, that imaginary line that splits it in half, it always starts with x equals, and since it's x equals whatever the x is in the vertex, it's x equals 0. So it's that line that goes right here. The y-intercept, the coordinates of the y-intercept where it crosses the y-axis is 0, 0, and the coordinates of the x-intercept, the only place that it touches the x-axis, is at 0, 0. Now, of course, these are not going to be the answers for all parabolas. This is just the parabola, the parent function, and the reflection of the parent function over the x-axis.